Welcome to Tales Unfolded. What if the pyramids of Egypt were more than just tombs of stone? What if they were machines of water, revealing a hidden technology thousands of years ahead of its time? Tonight, we dive deep beneath the sands of Saqqara, where ancient walls and mysterious trenches whisper secrets of hydraulic engineering that could rewrite everything we thought we knew about the genius of the Pharaohs. The genius of the Pharaohs. How the pyramids reveal a hydraulic technology millennia ahead of its time for centuries. The Egyptian pyramids have stood as silent sentinels of an ancient civilization, inspiring awe, speculation, and endless fascination. These monumental structures, rising defiantly from the sands of the desert, are not merely tombs or symbols of pharaonic power. They are repositories of lost knowledge. With each passing decade, new discoveries shed light on forgotten aspects of ancient Egyptian science and engineering, forcing historians to reconsider what humanity once thought it knew about the ingenuity of this ancient people. A recent wave of research has turned attention to something previously overlooked. Water, hidden beneath the sands surrounding the Step Pyramid of Djoser at Saqqara, lies evidence of an advanced hydraulic system, a network of reservoirs, basins, and channels that suggests the builders of Egypt's earliest monumental pyramid mastered techniques of water management. Thousands of years before such innovations were thought possible, this discovery challenges conventional assumptions about how the pyramids were built and hints at a civilization far more sophisticated in its environmental and technological adaptations than we often give it credit for. A forgotten chapter in human innovation, the Step Pyramid of Djoser, designed by the legendary architect Imhotep in the 27th century BC, has long fascinated archaeologists. Yet beyond its imposing limestone layers lies a hidden infrastructure that speaks of genius not only in architecture but also in hydraulics. Recent analysis of the surrounding plateau revealed the existence of what researchers now call the Manager's Causeway or Great Wall of the enclosure. This colossal stone barrier, stretching nearly 1,180 feet, was once dismissed as ceremonial or defensive in nature. However, new findings suggest it functioned as a dam, capturing seasonal floodwaters from nearby wadis. By creating a temporary reservoir capable of storing an estimated 14 million cubic feet of water, the Egyptians effectively engineered a sustainable water supply to support massive construction efforts. Seasonal floods would deposit nutrient-rich silt, enhancing the fertility of the land, while simultaneously providing the hydraulic power necessary for lifting and transporting stone. Hydraulics and the building of the pyramids. But how exactly could water be used in pyramid construction? Traditional theories propose long ramps of mudbrick and limestone stretching for miles, requiring immense manpower to drag multi-ton blocks upward. These theories, however, pose logistical problems. The ramps would need to be longer than the pyramid itself and would consume more resources than the monument they were meant to build. The hydraulic hypothesis offers a compelling alternative. Deep within Djoser's complex lies a massive trench, once thought purely symbolic. Closer inspection revealed that this trench was part of an intricate filtration and lifting system. The process may have unfolded as follows. Water storage and sedimentation. Floodwaters collected in reservoirs were channeled into basins where heavier sediments settled, leaving clearer water to be funneled into underground shafts. Hydraulic lifts, twin vertical shafts, linked by a 656-foot-long underground corridor, formed a primitive yet functional water elevator. By pumping water into the shafts, buoyant platforms carrying massive limestone blocks could rise under hydraulic pressure, an ancient version of the modern hydraulic lift. Placement of stones. Once at the desired height, the blocks could be maneuvered into position with relative ease, reducing the strain on human labor and increasing precision. This system, if confirmed, represents not only a brilliant adaptation of natural forces, but also a striking example of how ancient societies harnessed environmental knowledge to solve immense engineering challenges. Beyond architecture, sustainable engineering in antiquity. The significance of this hydraulic model extends far beyond construction methods. It suggests that the Egyptians approached monument building as an integrated environmental project. By redirecting water, controlling erosion, and depositing fertile silt, they transformed a hostile desert plateau into a dynamic, managed landscape. Moreover, the expertise required to design such systems indicates that knowledge of hydraulics was already deeply rooted in Egyptian society. Their irrigation canals, flood basins, agricultural dams, and sluice gates attest to a civilization that understood the principles of water management long before the Roman aqueducts or Mesopotamian. Waterworks became celebrated hallmarks of antiquity. This integration of architecture, environment, and resource management reveals the Egyptians not just as builders of stone, but as pioneers of sustainable engineering, a perspective often overlooked in the grand narrative of ancient history. Rethinking pyramid construction, the implications of these discoveries are profound. If hydraulic power played a role in pyramid building, then the traditional image of armies of laborers dragging blocks across the desert may need to be revised. Instead, what emerges is a picture of clever engineers leveraging natural forces to reduce effort, improve safety, and enhance precision. This perspective does not diminish the human element, it highlights it. The organization required to maintain such systems would have demanded meticulous planning, centralized coordination, and an intimate understanding of geology and hydrology. It also means that Egypt's Old Kingdom was not just spiritually motivated, but also technologically innovative, capable of blending ritual significance with practical necessity. A call to re-evaluate ancient sites. What makes this discovery particularly exciting is its potential ripple effect. If Saqqara harbors such hydraulic secrets, what might still lie undiscovered beneath the sands at Giza, Djoser, or Abu Rawash? Could the Great Pyramids themselves conceal water systems that aided their construction? The field of ARCHAEO-HYDROLOGY combining archaeology, hydrology, and geotechnical engineering may hold the key to future breakthroughs. By applying this interdisciplinary lens, researchers can uncover the hidden infrastructures that once animated ancient sites, revealing not just monuments of stone, but complex living systems tied to water, soil, and sky. The broader legacy of Egyptian hydraulics. Ancient Egyptian mastery of water extended well beyond pyramid construction. Their ability to regulate the Nile through dikes, reservoirs, and canals ensured food security for millennia. The concept of the annual inundation was not only agricultural was cosmological, shaping Egyptian religion, mythology, and kingship. The Nile was both lifeline and axis of power. Seen in this light, the pyramids may be as much monuments to water as they are to stone. Their very existence is inseparable from the harnessing of the Nile's cycles, embodying a civilization's intimate relationship with its environment. A civilization millennia ahead of its time. The hydraulic hypothesis forces us to reconsider how we judge the achievements of ancient peoples. Too often, we view history as a straight line of progress, with modern technology at the apex. Yet discoveries like those at Saqqara remind us that innovation is not linear. It is cyclical, adaptive, and often forgotten. What other hidden technologies lie buried beneath the sands of Egypt? Were the Egyptians experimenting with principles of mechanics, chemistry, or medicine that modern science has only recently rediscovered? Each revelation pushes the boundaries of our imagination, suggesting that the ancients were not only builders, but also visionaries, architects of both stone and water, creators of systems as elegant as they were functional. Conclusion: water, stone, and the eternal mystery the pyramids continue to puzzle and inspire. Far from being exhausted subjects, they open new doors with every archaeological season. The hydraulic perspective redefines these monuments, not as the brute achievements of forced labor, but as testaments to intelligence, innovation, and sustainability. As we stand before these timeless structures, we are reminded that human creativity is as enduring as stone and as fluid as water. The genius of the pharaohs lies not only in what they built, but in how they understood and adapted to their world. Lesson as vital today as it was 4,500 years ago. The pyramids remind us that true genius is not only measured in stone, but in the ability of humanity to harness nature, to adapt, and to dream beyond its age. As we uncover these forgotten technologies, we are not just learning about the past, we are rediscovering ourselves. If you found this journey inspiring, don't forget to subscribe to Tales Unfolded. Hit the notification bell so you never miss our latest stories. And leave us a thoughtful comment. We'd love to hear your reflections.